So my name is Anil Carmel. I am a solutions architect in the Network and Infrastructure Engineering Division of Los Alamos National Laboratory. And I am going to walk you through two things. Number one, how LANL implemented virtualization to reduce our carbon footprint, consolidate data centers across our campus, and enhance our green IT posture. And number two, our journey into the private cloud, how we evolved that investment into an infrastructure as a service offering. So let me begin by telling you a little bit about Los Alamos. So Los Alamos National Laboratory applies our expertise in defense science and technology to the broad spectrum of Department of Energy requirements, from basic research to ensuring the safety and reliability of the U.S. nuclear weapons stockpile. We are not only a nuclear weapons laboratory, we also do basic science as well. So we are located in northern New Mexico at about 7,500 feet. We are a 42 square mile campus with approximately 10,000 users. We have about 20,000 devices on our unclassified protected network with 14,000 Windows systems, 3,000 Apple systems, and roughly 1,500 NICS systems. So that's our unclass space, and this is, in essence, a picture of what the laboratory looks like. So let me begin by taking you on our journey. So a journey is defined as an act or instance of traveling from one place to another. So the first step on this journey for us was to virtualize our infrastructure. So let me take you back to where we started to tell you where we're at today. So very basic, what is virtualization? It is the process wherein you abstract the operating system and installed applications on a specific machine and put it on a hypervisor to take better utilization of the underlying hardware resources. So what challenges did we face? About 4 years ago, we had roughly 300 Intel-based HP ProLiant and Dell servers with an enterprise approach to imaging and patching and backing up these systems, hosting a variety of different types of environments, roughly 32 plus web applications, 50 Citrix servers with a variety of different application sets, Notes, Domino, WebSphere, SharePoint, Project, SQL Server, Exchange, and whatnot. So we had to build a business case to virtualize this infrastructure. So here are some of the gaps that we found in a physical environment. Number one, servers distributed in multiple data centers. We had a fair number of data centers on campus, and we needed an effective way to reduce our footprint from a data center perspective. By reducing the number of servers that we require on our facility, we can enable consolidation and reduce the number of data centers required on campus. Limited data center floor space, power, and cooling. We were running into the proverbial brick wall in terms of power and cooling in our site. So we needed to, again, reduce the number of servers that we had in our facility to enhance our computing posture. Need to retire unsupported platforms. How many of you, by a show of hands, have systems out there that are running 7, 8 years old on a piece of physical hardware that you don't have the installer for the application that's on there, but it's mission critical? Yeah, there you go. All right, so this is a very real problem that virtualization solves for us. By being able to move this workload onto a virtual server environment, you now can protect that application. Slow server provisioning cycle time. How long does it take to buy a server, rack it, stack it, and provision that machine, install the application, and turn it around and give it to somebody? Roughly, we found on average our metrics showed about 30 days to rack and stack and deliver a system. We needed to be more agile. So we needed new environments provisioned without purchasing and installing additional physical servers rapidly. And then limited hardware for disaster recovery. We needed a way to provision systems very quickly and yet have DR capabilities for those systems, and virtualization provided that for us. So what did we invest in 2006? 2006, we purchased 13 HP ProLiant DL585 servers. They're dual-core AMD Opteron processors with 32 gigs of RAM, multiple network and fiber channel cards, connected to an HP EVA storage area network with roughly 250 terabytes of storage. So a couple EVA 8000s with 75 terabytes of storage, an EVA 6400 with 50T, and a shared disaster recovery EVA 8100 with 50 terabytes of storage. That shared EVA 8100 uses active SAN-to-SAN replication using HP continuous access replication between EVAs for disaster recovery purposes to protect our data. So we purchased a couple tools to help us walk this journey. One of the tools we bought was PlateSpin Recon. This is very important. You need to invest in a capacity planning tool because it's very difficult to size what you need if you don't know what you have. So we made an investment in PlateSpin Recon to gather server utilization metrics on our existing physical servers so that we could determine what the virtual server sizing should be. And those metrics were used for the P2V workloads. At the time, about 4 years ago, we bought PlateSpin Portability Suite to migrate those virtual servers into our physical servers into our virtual environment. PlateSpin Portability Suite also allows us to take that virtualized workload and move it back to a physical environment. So it offers us that flexibility of not only P2Ving, but also V2P. And we invested in a backup technology at the time, VisionCore's vRanger with VMware Consolidated Backup to back up the VM for DR purposes. So where do we stand today? We have roughly 400 VMs running on that 13-server cluster. Average resource utilization of that cluster is about 85% with a 30-to-1 consolidation ratio within that cluster. So it's a very high consolidation ratio, and that was based on capacity planning. So we sized the virtualization workloads based on the actual utilization of the virtual or the server environment. We decommissioned 105 physical servers, and we retired 3 data centers. So let's talk ROI. Our ROI projections initially called for an ROI in roughly 2 years. When we started this project, we actually achieved ROI in 9 months from the inception of the project. So the ROI story is very compelling in the virtualization environment. Energy savings is definitely not inconsequential. When we calculated the energy savings derived by virtualizing these workloads, we came up with something like 1.8 million kilowatts per year of energy saved by implementing virtualization. And we calculated a cost avoidance and savings of roughly $2.8 million per year. And as a result, we're the recipient of the 2009 NNSA Best in Class Pollution Prevention Award for Server Virtualization. NNSA is the National Nuclear Security Administration. As a government employee, I'll use a lot of acronyms, so apologize in advance. So, journey to the private cloud. So we've made this investment in virtualization. That's great. So now, how do we take that and make it into an infrastructure as a service offering? So a lot of people think that if I've invested in virtualization, I have built a cloud. I have all these resources, and it's abstracted, so it must be a cloud. Well, I'm here to tell you today that virtualization is not cloud computing. Just because you have virtualized your workload does not mean that you have built a cloud. So what's the next step in this journey? Well, the next step in this journey is to build a cloud. Okay, so what is a cloud? By a show of hands, how many people know what a cloud is? Well, that's actually really good. At all these presentations I've done, there's been a much lower show of hands. So I'm going to walk you through what the definition of a cloud is as per NIST. So the NIST definition of a cloud is cloud computing is a model to enable convenient, on-demand network access to a shared pool of configurable computing resources that can be provisioned rapidly and released with minimal management effort or service provider interaction. This is as per NIST. So this is the definition that we used when we defined a cloud. So what are the essential characteristics for cloud computing? Number one, on-demand self-service. You need to be able to provision compute capacity without human interaction. Number two, broad network access, being able to access those systems via heterogeneous, thick or thin client platform. Number three, resource pooling, being able to serve multiple customers using a multi-tenant model. Number four, rapid elasticity, being able to quickly scale those resources in or out based on demand. And number five, measured service, being able to monitor what you're using today and report on that. These are the 5 essential characteristics, as per NIST, for what a cloud is. So, what are some service models? Again, as per NIST, for what a cloud is. Well, number one, software as a service, being able to access applications in the cloud. Number two, platform as a service, being able to develop applications in the cloud. And number three, what we're here to talk about today, infrastructure as a service, being able to access those compute resources in a cloud. So let's expound on that infrastructure as a service for a moment. What are some deployment models around that? Well, number one, private cloud, being able to create a cloud solely for an organization. That's the model that we chose to do. Number two, a community cloud, being able to share those resources with several organizations with shared concerns, mission or security requirements. Number four, public cloud. There's a variety of public cloud vendors out there today that are available for general public consumption. Or a hybrid cloud, a combination of two or more clouds to create a public-private cloud partnership. So again, this is as per NIST's definition. So we Los Alamos opted for number one, the private cloud, and we are here to announce today infrastructure on demand. Infrastructure on demand is the Department of Energy's first infrastructure as a service private cloud. We have built a self-service web portal to automatically request and provision these virtual servers on demand. Green IT is very important to us. As a Department of Energy laboratory, we are very conscious of the energy that we consume. So the energy savings is dynamically computed and displayed on this website. This model also includes lifecycle management and chargeback. I feel these are two very important components to a cloud. Lifecycle management, what does that mean? We in IT are very good at turning on systems. We're horrible about turning them off. So in our model, what we've done is we have created a lifecycle management strategy where when you request the system, you can have it for a maximum period of 1 year, after which time you must renew that system, and that's fully automated. And I'll discuss that in detail as we walk this road. From an operating system support standpoint, we support Windows, Linux, and Solaris. Full backup and recovery of the systems is some of the features that you get by using IOD. Government guy, use acronyms. VMware system administrators will support the underlying infrastructure. There is no ongoing infrastructure refresh costs passed along to our users. It's all part of the service. And the new virtual servers are automatically provisioned from this portal. The requester is responsible for the security plan that the system resides within and the system administration and maintenance of the operating system and applications. So what we're saying is if someone requests a system through IOD, we, VMware folks, do not own that virtual server. You do. It's your system. You own it. You maintain it. You install the applications. You support it. VMware folks support the underlying infrastructure. So what did we invest in? We made a significant investment in HP ProLine C7000 blade infrastructure using full Virtual Connect Fiber Channel and Flex 10 Ethernet. Each C7000 blade chassis has 6 10 gigabit network feeds that feed directly into our core. Our core is fully 10 gigabit. So we are running 10 gigabit all throughout our core. We have quite a bit of bandwidth and throughput in this infrastructure. We're using HP onboard administrators and System Insight Manager and RDP, so HP best practices around managing that infrastructure. And we've chosen two types of blades. We have an HP ProLine BL460 blade. These are two quad-core Intel Xeon processors with 60 gigabytes of RAM. And then what I like to affectionately call our super blade is our BL490C virtualization blade. This is a 6-core Intel Xeon processor blade with 144 gigabytes of RAM and an SSD for the ESXi boot image. So we also had to scale up our storage. So we made a strategic investment in NetApp and purchased a NetApp V-Series and about 2 petabytes of Tier 2 SATA storage for this cloud offering. Now, the nice thing about this solution is we've already made this investment in HP storage. We don't want to throw away that investment. So the NetApp V-Series allows us to virtualize our existing storage arrays, leveraging the investment that we already have, and provide that infrastructure, storage infrastructure, to our infrastructure on demand offering. It also gives us data deduplication. It allows us to create snapshots for backup and restore, rapid provisioning of virtual desktops using the rapid cloning utility, natively integrates with our vCenter, and then presents storage via NFS up to our vSphere 4.1 environment. So the NetApp is our storage investment that we've made for IOD. So how did we do it? So I've done quite a few of these cloud presentations and talks, and I've heard a lot of people talking about this is great, but we're going to end up at this cloud computing nirvana. But no one quite tells you how we got there. They tell you, this is great. It must be some kind of miracle how we got there. Well, we need to be a bit more explicit. Well, I'm here to show you what is under the covers. So, what are the 4 essential characteristics of IOD? Number 1, we have a web portal that we have built for ourselves. It is a front end displaying information regarding the service and a form to request the system. Our automation engine, which drives our workflow, is SharePoint. We have used SharePoint to do our lifecycle management, and it is our integration point for internal systems, including chargeback and our hostmaster registration system, which is our IPAM solution. Now, the next two solutions, you're probably looking at the slide going, what's that? Those two solutions you're going to hear more about. We were given early access to beta code to implement the solution. So VMware vCloud Director is our web-based user interface to consume cloud resources. It is the engine that enables the private cloud. And security in the private cloud is also very important. You'll hear more about that shortly. Again, we're given early access to beta code. This is VMware's vShield application and Edge. It is a virtual appliance to implement, manage, and maintain the security policy within our private cloud. And it is what enables security in the cloud. So security is a very big deal for a government agency like us, and it should be for your guys as well. Today, that hasn't been a story that's been told very well. So let me take you on a side security journey. Traditionally, security has been very expensive. You have specialized hardware appliances that you have to employ in a physical environment, and you have multiple point solutions in a physical environment. It's also very complex. You have a spaghetti of rules across your Cisco's or whatnot, in ASAs or whatever you have in your environment that you have to manage and maintain, and it's very rigid. You have a policy that's directly tied to your implementation. It's not virtualization or change aware. So you don't really have visibility into a virtual environment. So what does security look like in a virtual environment? Well, it needs to be cost effective. You need to have a single virtual appliance with a breadth of functionality and a single framework for this protection. Instead of a very complex set of rules to manage, you need a simple way to manage those rules with no sprawl in these rules or VLANs or agents. And visibility for VI admins and network and security teams to look into this infrastructure with a simplified methodology for compliance. And instead of a rigid policy, you need to have something that is virtualization and change aware. Program it in one place and execute it anywhere with rapid remediation. So this is what a traditional network looks like today. In a network like ours, we have air-gapped networks with different classifications of data within those air-gapped networks, and we have this thing that we call enclaves. That's depicted by service A, B, and C. Those enclaves have types of data that are grouped based on need to know, based on the type of work that specific researcher is doing. So we have these different enclaves in these different unclassified networks that are air-gapped. There's VLANs that segregate that. We have hardware appliances. It works very well in a physical environment, but how does that tie to a virtual environment? Well, so we have these air-gapped pods, right? Now, in a virtual environment, you can build mixed trust clusters with vShield application to build your secure private cloud and secure your secure private cloud. So here's a depiction of those air-gapped pods, as we talked about earlier. So physical security stops right there. So with a mixed trust cluster leveraging a solution like vShield application, you can now have visibility and security in your virtual infrastructure and drive that into your secure private cloud and have cloud security, mixing different organizations and securing your cloud. So let me talk to you a little bit more about what that looks like. This is our security in our virtual infrastructure. So we have we'll speak to Virtual Data Center 2. Virtual Data Center 2, it takes that enclave concept and brings it down into our virtual environment. Now, we've done something a bit further than just creating an enclave. We've created a sub-enclave of virtual desktops within the main enclave. Now, this is very important because that virtual desktop enclave has rules that prevents lateral movement from one virtual desktop to another. So if an attacker were to take over a virtual desktop, he can't go laterally. And that's based on the security policies that we have built using the vShield tools. Now, between enclaves, we can do inter-enclave communication and in the virtualization layer based on rules that are defined in vShield application. So that's all been built. One of the things that we've gone and done as well is if a VM gets compromised, it can be moved from one of these enclaves into a remediation enclave that has a specific set of resources to remediate that system that doesn't have network connectivity. So it's immediately taken offline, and that's scripted and built with our IPS solution. So our IPS solution kicks off a workflow that moves systems into a remediation enclave. So this is virtualization or virtualization security in IOD. So it's also adaptive. So it's not just security on one host, but that security follows the VM. So the security groups that the enclaves reside in are just a VM construct rather than a physical server construct. And the security groups are enforced irrespective of where that VM resides. If it moves from one host to another, the security follows that. So you can mix VMs from different security groups on the same host, leveraging the security that we've employed in infrastructure on demand. So what does the future look like? That sounds really good, and we actually have all this baked and built in our IOD offering today. So today you've got three different teams. You've got a network admin team, you've got a security administrator team, and you've got a virtualization team that monitor this infrastructure. Well, in the future, you need a way to seamlessly integrate the functionality between a physical security environment and a virtual security environment. You also need some type of visualization tool to define, implement, monitor, and refine the policies that are in your physical infrastructure, because it's not just good enough to P2V the workload. You need to P2V the security policy with it. So P2Ving the workload is one piece. Now that the visualization tool identifies what that virtualization security or physical security is, now you take that security and you transform it and you migrate it into a virtual environment, and using an automated script via a common policy framework. This doesn't exist today. This is the future. And it needs to have role-based access control. So the previous slide depicts what we have today as far as security in a virtual environment. This is the next step. So this is a very oversimplified slide of the workflow that's kicked off to build this private cloud. So iod.lanl.gov is our portal that users log into. A user requests a virtual machine in IOD, and it kicks off a SharePoint workflow. SharePoint, as I mentioned, is the automation engine that drives our private cloud. The SharePoint workflow kicks off a web service using the vCloud API into VCD, creates a vApp within VCD in a MAC address, reports back to SharePoint that that vApp has been successfully created. Another web service is kicked off to register an IP address and MAC address, system owner and data type, in our IP address management system. We don't have DHCP on our network. All our IPs are static, so we have a web service to go off and register that IP address for that system. Returns the IP address and whatnot back to SharePoint, and then SharePoint kicks off another web service to tie that IP address to the MAC address in the vApp of VCD. Let SharePoint know that it's finished that, and then sends off an email to the user saying, the server's been created, you may now consume it. So let me walk you through what that looks like. So without further ado, I'm going to show you for the first time publicly DOE's first Infrastructure as a Service private cloud, Infrastructure on Demand. Infrastructure on Demand has four fundamental tenets that I felt were important to include in this cloud. Number one, green IT. That number of kilowatt hours saved per year, that number is dynamic. It is truly environmentally sustainable computing. So as we deploy more virtual servers in our environment, that number continues to grow at a pace that mimics how many servers have been actually stood up in the virtualization environment. So, as I said, it's environmentally sustainable computing. Deploying a virtual server as opposed to racking and stacking a physical system results in considerable power savings. But it's not just power savings, you're also reducing your electronic waste. So, if you click on See for yourself, what we've done is we have graphed the amount of energy savings over time based on our virtual machine growth in our environment. Now, we need to map that back to real-time savings. So you can see in December of 2009, we were saving somewhere on the order of 1.3 million kilowatt hours of energy per year. So it takes about 8,900 kilowatt hours of energy per year to provide power to one average U.S. house. Well, with the amount of energy saved annually through IOD, Los Alamos can power 216 homes. So that is a number that's dynamically computed, and it is a real-life savings indicator of the amount of energy saved by deploying virtualization and cloud computing at Los Alamos. Number two, has to be streamlined. Push a button to create a server. Instead of buying costly, cumbersome servers, IOD lets you control a resource pool of processing, storage, and network, and allows you to deploy server capacity on demand. You click this button, and you go to the form to request the server. It needs to be scalable. You need to be able to scale systems up or down based on demand within your budget. Before, it took roughly 30 days to provision a server and rack it and stack it and deliver that system to a user. Now we've reduced it to 30 minutes. And it needs to be secure. We've gone on that security journey. You've heard where we went. It is safe, secure, and reliable computing, employing defense in depth to ensure the confidentiality, integrity, and availability of the virtual server offering. So, what do users need to do? They simply click this Create Server button, and they're taken to an authentication screen, because we're not just going to let anybody request a server. We want to know who you are. So this is a Los Alamos authentication screen that uses our two-factor authentication to authenticate the user. Once they have authenticated, they are taken to our request screen. Automatically fills in the different fields as you type in what we call a Z number, which is a unique identifier for each individual at the laboratory. So we request 3 pieces of information in terms of who is responsible for the system: the requester, the system owner, or security responsible line manager, and the system administrator. Those are the 3 people that we want to know are tied to this system. That's all captured in our SharePoint workflow in our SharePoint system. The next piece is cost code. We need to capture the cost code for this particular system. It's got to cost something to somebody, and that's part of that chargeback mechanism we talked about. There's a notion that it's virtual, it's free. You can give me 1,000 systems, and it doesn't cost anybody anything. Well, in our model, we charge back for the resources consumed in IOD. If you put an invalid cost code in here, it will automatically tell you you have an invalid cost code and will not let you proceed until you put a valid cost code into our system. Define the system name. As long as the system name doesn't exist on our network, you can go in and put that in there. Otherwise, you'll get an error message saying that there's a problem. And then that system expiration date. Now, you notice some of these things are redacted. I can't talk to those, so don't ask. The system expiration date is the date wherein that system expires. You can go up to a year to request the system and keep it on the network. And it's very simple to renew it. So we generate 6 emails to our users. 30 days before the expiration date, we send you an email to those 3 people, the requester, the system owner, and the system administrator, saying, your system is about to expire, would you like to renew? And you simply say renew in the number of days, up to 365 days to renew the system, and it's automatically renewed. Then we send another email 10 days before. We're going to turn off your system. Please renew. Same thing. A day before, we'll send another email. We're going to turn off your system tomorrow. Please renew. The day of, we just turn it off. And then we send you an email saying, we turned off your system. Would you like to renew? If you don't renew, then we keep going down that journey. So 10 days afterwards, we say, your system's still off. Would you like to renew? And then day 29, we send you another email saying, we're going to delete it. Do you want to renew now? And then day 30, we delete it, and it's gone. But it is backed up on our tapes for 7 years. So we take all these steps to turn off the system because we don't want just an unpatched system sitting on our network. And we provide an ample communication avenue back to our users saying, this is something that you probably want to do if you want to keep the system online. So that's very important, lifecycle management. Cost. There has to be a cost to the user. So what we've done is we've written a dynamic algorithm based on the server operating system that you select. So here our average system is 1 CPU, 1 gig of RAM, 20 gig of disk. We recharge our users $67 per month for that system. Server 2008, 1 CPU default, 1 gig of RAM, 40 gigabyte disk. See these little sliders right here. As you move these sliders up and down, the cost changes dynamically. So our users know before they put a request into the system what it's going to cost them. So that's part of our chargeback. So they know right before they put the request in, this is the cost. So once they put the request into the system, the request then goes to the security responsible line manager. So this is part of our security policies that there is a little bit of human interaction because we have to know that the security responsible line manager approves the system and is going to accept the charges to their cost code. So we send an email to the SRLM saying, here's the system. Do you approve this? Simply respond with approve. Once they respond with approve, the workflow is then kicked off to create the system. Creates the system in IOD, defines the appropriate security policies based on the security plan that the system resides within, and then sends an email back saying you now have access. The user then clicks on this customer login button. That customer login button takes them into vCloud Director. This is a screenshot of beta code of vCloud Director. This is tied to our Active Directory implementation. It's fully web-based. You go to a web-based portal to consume the resources in VCD. Users click on the My Cloud button. They see systems that are set up for them. They can do pretty much anything that they could do from vCenter in a web app and consume the application from the web. So you can power on a system from the web. You can power off a system from the web. You can access the console of a system from the web. Fully self-service and available for users. So every journey begins with a single step. You have to build best practices around virtualizing your workloads before you take the next step to build a private cloud. So for those of you that haven't taken the step of virtualizing, I encourage you to take that road, take that step and virtualize. And if you have taken that step to virtualize, take the next step after you've built best practices around virtualizing that workload to build a private cloud. With that said, that's IOD. I'm opening up for questions. Yes? So SharePoint, from an automation workload perspective, today suited our needs. So there are certainly other automation solutions that are available. That's the solution that we had in-house. That's the one we chose to select. We had SharePoint developers that could write that workflow for us. So there are other ones that you could use, but it does work for us. That's, yeah. That's something we are actually considering is packaging this up, but we'll see. Yes?
What type of SLA would have to offer this service?
Right. So that's a very good question. From an SLA perspective, what we have... Oh, I'm sorry. Let me repeat that. What type of SLA are you offering with this particular the solution? So our SLA today, we have 4 nines of availability today in our infrastructure. So that's our current SLA model, and we plan to continue that as we go live. If a system, for whatever reason, the hardware goes down and we do not meet our SLA, we don't charge that customer for that month, and we won't charge them that cost for that month. So that's our SLA, is if we don't meet our requirements, we'll be publishing metrics on IOD that show this is our uptime and availability so that users know if there's a problem with the virtualization infrastructure, we're not going to charge you for that particular month if we don't meet the 4 nines of uptime. So that's another area that we need to expose within this environment. So that's additional metrics that we need to put out on the site. So we're investing in tools to put those metrics on the site to show what the actual performance is within the virtualization infrastructure. Now, I know that there's a lot of folks that get questions that, or the finger pointed at the virtualization offering saying, it's the virtual infrastructure. It's the virtual infrastructure's fault, right? So that's part of publishing this data point and showing folks off the bat, it's not the virtual infrastructure, it's most likely an application problem. So, yes? Right. So really to get to where we got today takes a couple things. You have to have vision as to what you want to do, and then you have to execute on that vision. We spent a year developing the system. So it took about a year from the inception of the idea of we want to build a private cloud to delivering what we have today. And that was bringing in, handpicking people to work on this team to build the different components of this infrastructure. So it took about that to get to where we are today and to build this framework and really define all the rule sets and policies and procedures and define the requirements around IOD. Now, there are some things you can, obviously VCD, that's something you can get off the shelf, and if that meets your needs, that's great. And VCD is an amazing offering, and vShield, again, another amazing offering. If those meet your needs, definitely you can just plug those in and get that off the shelf, and that'll work well today. Yes? How do we back up the systems? Good question. So the backups today use vRanger. We employ a disk-to-disk to tape methodology where we back up systems to disk, and then from disk we go to tape for 7 years. So we employ a weekly backup of all our systems to disk, and then from disk we go to tape. Now with the NetApp, we can do snapshots. So we can do daily snapshots with the NetApp and then go from there every 7 days to tape and skip the disk. So the next step is to go to the NetApp, and that was just a recent investment that we made to back up our infrastructure as well as manage our existing arrays.
So is your store web-based and will be able to get the disaster coverage for your product help desk, or do you have one enable where you can restore from a snapshot or backup?
Right. So the restore capability isn't exposed today. There's some limitations to exposing that today. So that's something that's still manual. You have to send an email to our folks to do a restore. That's a Gen 2 offering. So that's not something that's available right now. Automated-wise, that's something that will be a Gen 2 offering. Yes? Oh, so what about systems that require more than 8 CPUs or a lot of resources? So what we've done is we've locked the virtualization offering here at 4 CPUs and 8 gigs of RAM for the average system. Now, for those systems that require more, we have 2 customer models. So the one customer model that you saw here is our individual customer model. We also have a large customer model wherein we provide a set of compute resources that they can consume directly within VCD and deploy their own systems, and we charge them back based on that large customer model so they can deploy larger systems if required. But for the individual systems, we send you through the portal and we lock it to that smaller size. So the workloads that we're targeting are the vast majority of the workloads that we have seen, which are your 4 CPU, 8 gig of RAM type systems. Yes? Good question. So the question was around patch management. So the patch management is solely the responsibility of the system administrator, the system owner, and the system requester. We have on our network IPS solutions and IDS solutions that will automatically block your system and put it into that remediation enclave if we find that that system has been compromised. And it's fully automated. We will move it, and we will take it off the network. So that's part of the cloud, and that's actually physical security and virtual security. That's in place today. So that's how we deal with it. Patch management is the user, and then security, if you don't meet it, we'll take you out.
What is your SLA based on? I mean, you can't really be just pure uptime because you got system administrators that obviously they can decide whether they want to patch or not, right? And that controls the operating system uptime. So what is your SLA for? What's that based on?
The 4.9 is for the SLA of the underlying ESX host infrastructure. It is not the SLA of the virtual server. The virtual server, the SLA for that is whoever requested it. The requester is responsible for the virtual server. The VMware team is responsible for the ESX host. So the SLA specifically is only for the host and the infrastructure itself underlying the virtual offering. Yes. I'm sorry, I didn't hear that. How do you virtualize a Solaris environment? Solaris is a offering that's available within ESX today, so it's just another option for us to select. So we built a Solaris 10 template and x86. Sorry, it's Solaris x86. So we just built a Solaris x86 template. Yes.
Any pushback from the users on your IPS to 9.1?
That's actually not new in our physical environment. We've had that in place for years. So the new part is it's now in our virtualization environment as well. So the physical environment has had that IPS IDS in place for years. That's the way we deal with it. So it's just now extended. Yes.
You said the return on investment. Did you have any challenges working with the finance department or some organizations might be capital investment, and then you're taking it to look at the operational investments, and how did you involve based on finance across the whole drive and buy into the software?
Good question. So the question revolves around how did we get the finance folks, our CFO division, to adopt this model and really allow us to provide the service back to customers. So what we did is we created a model wherein users have money, and instead of them going out and spending that money, they give that money to us. They sweep that money into our charge code. We go buy the infrastructure instead of them buying the infrastructure, right? So the money is still being spent, but it's being sent to the network and infrastructure engineering division first, before we spend it on virtualization hardware and infrastructure and software licensing and whatnot, and then provide that service back to the user. So we have a hardware services rate and a software services rate. And the software, well, let me take it back. A hardware rate and a services rate. The rate that you saw here is a combination of the hardware and services rate. So they you can give us, if you're a large customer, you give us a large chunk of money, and that applies towards the hardware rate. You get this pool of resources that you can consume. If you are an individual customer, you give us the amount of money that you saw on that portal, and we buy servers as the money comes into our charge code. Yes.
You have a licensed application software.
The software licenses within the cloud?
No, within the guest OS.
Within the guest OS. That is solely the responsibility of the system requester. So the system requester is responsible for the licensing of any applications or the OS of the servers that reside on IOD. That's not the responsibility of the virtualization team. That's the responsibility of the requester. Yes?
In terms of backup, I'm assuming that if you leave that by default, how do you deal with customers who want long-term protection?
So, so long-term protection, meaning they want to keep the system for like 10 or 20 years, or?
They want to back it up. Let's say they tell you they want 10-year every day, which is ridiculous.
Mm-hmm.
They're asking that.
Yeah.
How do you deal with it? Do you say this is what we offer and that's it, or are you flexible?
So the flexibility of backup is within the guest. If you want a higher backup rate, you can install your own agent, and you can back up to our tape silos and back up the individual data at whatever rate you see fit. We, the infrastructure folks, will back up your data at this rate. If you want a higher backup rate, you can install your own backup agent, and you can back it up to whatever you want to back it up to. But we support this. Yeah, the default for today is, with the Vision Core product, it's a disk to tape, 7 days, and then a monthly to tape, and the tape is kept for 7 years. So that's our window today. With the NetApp, we're going to be doing daily snaps with a 7-day to tape. So we'll actually be having more of a backup with the NetApp. Yes. No, that can be mounting the snap to a machine that has our Tivoli agent on it. So we use Tivoli. So we just mount the snap to a machine that has the Tivoli agent, and the Tivoli agent just backs it up to tape. Yes. It's an algorithm we wrote. It's LANL special sauce. So, that's one of our algorithms that we wrote.
You mentioned from the use plate spin as part of the data collection process. Can you comment on how that went and how valuable that exercise was for you as you decided that you're in that?
Yes. So the plate spin product actually was pretty instrumental in our virtualization offering. It was something that we used to size the resultant virtual offerings from physical. It's completely agentless, so you don't have to install an agent on any of the physical boxes. You just say, I'm going to monitor this system. You have rights, obviously, so you get admin rights to that system. It gathers these metrics. It provides you these nice reports that say, this is what this current system is using today, and our calculations came up with roughly 10% of resources that were being consumed by that physical operating system or physical machine. And then based on that, it gave you a sizing guideline of this is what the virtualization offering should look like. And we created a virtualization offering that matched the physical workload. Yes? It's a multi-data center model, so we replicate from one data center to another for DR purposes. And then if our primary data center fails, we have an automation script to fail over everything to our secondary data center. So that's that site-to-site replication that we talked about, array-based replication that the NetApp also will allow us to do. So it's using truly a multi-data center model. They have RDP access to their servers. They can go to the web interface to consume it if they want console access, if they want to power on or off the machine or whatnot. But typically, most users are going to consume it via RDP access or SSH. Yes?
How long has it been in operation, your infrastructure as a service? What's the demand curve been like? What's every day, 3 weeks?
So we did an internal launch of this last week, and this is our first public launch. So our DOE's public launch is today. So the demand curve is yet to be seen, but we have invested significant effort and resources in building this cloud. So this is our public launch. Yes. Capacity awareness. Mm-hmm. Yes, right. So we made a big investment in infrastructure, really big investment in infrastructure. We bought lots of hardware to really get ready for this demand. So that's, as you size, that's something you have to watch, right? So we will be keeping an eye on it daily so that as resources get consumed very quickly, we can stand up new resources. And we do have an avenue with our procurement folks to get systems in within a day if we need to and plug those in. So, and then of course it's all based on costs, dollars. So as the dollars flow in, we can go buy more resources. Right. So at this current juncture, we haven't made that investment yet, but that's the next step. These are all Gen 2 type things. So that's our investment was we're going to buy infrastructure, and then we're going to then build the capacity awareness based on the existing platform. Yes.
Do you have a plan to separate on and on?
We do. We have a strict Devil beta production environment, so users can request systems within Devil, within beta, within production, and we do have that segregation, but it's based on the user to pick which environment they want to go in. And that's part of that security plan thing that we talked about, right? So based on the security plan that you select, you get put into that specific type of environment that has limited access to beta, which has limited access to production. So I'm going to take... They're all on the virtual platform. I mean, there's physical environments too, but in this case, it's all on the virtual platform. But it's segregated using that enclave concept that we talked about, right? So I'm going to take some questions from the back because I've been pointing in the front, so I'm going to go right back there.
It looks like a lot of the partners are providing portals now. What made you go with providing your own versus maybe adopting a partner portal, or is there any of these similarities, or
Right.
continue to find results as far as the commercial provider portals?
So from our perspective, at about a year ago, when we kind of had this vision that we want to do this public cloud or private cloud thing, there really wasn't a commercially available portal that we could point to and say, this portal meets all of our needs. So as we started building around this and putting the pieces together, the web-based portal made sense for us because we wanted to do the green IT savings and show information back to our users and whatnot. So there are commercially available solutions today. The pieces that we built fit our needs, specifically around lifecycle management and chargeback because of the way that our chargeback system is set up and the way that we sweep cost codes and whatnot. We really had some specific requirements around that. So that took some time to develop, and SharePoint for us was the vehicle that we used, and the rationale that we used because of our integration points internally. Yes?
How many reservations did you execute before going live?
Reservations in terms of?
Provisioning hardware, provisioning virtual machines.
We did hundreds. I mean, we did hundreds we did load tests. We load tested the web portal. We load tested the SharePoint site. We load tested VCD. So we threw quite a bit of load against all of these components to ensure that this would scale very quickly. Yeah. So, I mean, it could go to thousands, but we did it by the hundreds. So. So virtual machine escape and hyperjacking, those are theoretical concepts that, I mean, unless there are specific types of vulnerabilities, we do have mitigation and defense in depth at our host layer, certain things that I can't talk to you about that we have in our environment to secure our infrastructure, but actual documented virtual machine escape, there's been talks about this is how you do it, but actually doing it is another thing. And we've actually built protections and controls around that I can't talk to you about here. You have to have a clearance. But there are protections and controls that we've built. But the actual, has someone done it? That's remains to be seen.
Regarding the portal, how did you guys code it, and how did you decide how the interaction works, whether APIs or
Yes. So for us, it's really about collaboration with industry and government. We don't really necessarily want to write our own code. We want to leverage industry's great work, and that's what you're seeing here is a partnership with industry and government. We rolled some of our own, but we leveraged industry as much as possible. So the points that specifically relate to Los Alamos' implementation that interface with our own systems, we wrote our own. Anything that interfaced with commercial systems, we used commercial resources. So we didn't try to build as much of it ourselves. We wanted to really determine what that breakdown was. And the breakdown was, if I'm integrating with something that's specific to an internal system, we'll write it. If I'm interfacing with something that a commercial system can do, I'll go buy it. So that was really our decision point. Yes?
How did you deal with multi-tenancy? I know you mentioned vShield. Did you rely exclusively on vShield, or do you have any technologies that you leverage?
So there are other security technologies in this environment, which I'm not authorized to disclose. That's one of them that work really, really well. There's other things that we have done from a security perspective that interface with our IPS and IDS that I can't talk about publicly. There are other virtual security appliances that live in this environment. That is the big one. That's the big one from a security perspective, though, vShield. And that was a gap that existed before that has been filled. So, and that's part of leveraging great industry tools that have been written. VCD and vShield for us were the tools that we leveraged for that. Yes? Say again? Thin provisioning? That's a good question. So from that perspective today, we're thick provisioning to the end user, but since we're using the NetApp array allows you to do some data dedupe. So we're relying on the NetApp array to do the dedupe as opposed to thin provisioning and then deduplication on top of it. So that was what we chose to do. Yes? Production stores run on our EVA environment, which is virtualized by the NetApp, right? And then we have some offerings depending on the type of workload that can run on the SATA stores. So we have both. That's the nice thing about the NetApp is I can still use my EVA investment. I'm not wasting it because I'm using the NetApp to virtualize the existing storage arrays, present it still via fiber channel back up. But I can also use the SATA storage via an NFS mount. So I can use both. Mm-hmm. So that's a great question. So challenges that we faced getting adoption, it really is a prove it and they will come. It's not build it and they will come, it's prove it and they will come. So we had to prove to our internal customers that it's cost effective, it's safe, it's secure, and it's reliable. So you prove to them that it's available and then you make it easy for them to consume. So by doing that and building not just the virtualization team, but building a easy request process and security baked into it, that is how we achieved our buy-in. So we had to prove it to ourselves and then prove it to others to really build a critical mass.
How long did you get to this point?
It took 4 years. I mean, we started our journey in 2006, virtualizing our workloads, right? So if you haven't virtualized your workloads today, the first step on this journey is to virtualize your workloads, build a business case around virtualization, and then virtualize. Once you've built that business case and virtualized, don't immediately go build a private cloud. Then build up your best practices around your virtualization practice. Then build your private cloud. Mm-hmm. Yes.
What would you do differently? You're here now, you're just launching. What would you do differently if you had to do over?
If I had a do-over, don't we all wish we had a do-over button? So at this current juncture, because we just started, we haven't necessarily seen a lot of the different idiosyncrasies that are in this environment. A lot of things really work really well. I mean, we're using ESX SI 4.1. We've upgraded our infrastructure to that. We're vCenter 4.1. So we're 4.1 all the way through. There really hasn't been a lot of idiosyncrasies that we've fell into today. But we won't really know until we get a critical mass of hundreds and thousands of systems that are riding this infrastructure to know what we should have done. So today, we're pretty happy with what we built. it seems to work really well for us. We've done our internal load testing and whatnot, and it's scalable. So I only have a couple more minutes, so I'm going to take maybe 2 more questions, and I'm going to go ahead and I'll be here afterwards to answer any questions that you have. So.
You said hundreds of thousands. How big do you think it's going to get?
Hundreds or thousands. So let me qualify, not hundreds of thousands, hundreds or thousands.
I challenge your answer because you already had hundreds of systems. When they were physical systems, when they were hard to buy, when they were hard to provision, when you had to talk to 15 different people to get them to stand up, you've taken all that away. You're now so easy. I challenge you. You're going to have 10,000 VMs.
With somebody paying for every one of them.
Even if they paid for it, can you support it?
We could support it. I mean, if we've made it easy for the requester to create a system, what we've done is we've empowered our workforce to be agile. We as an IT organization have given a tool to our users to rapidly provision systems when they need them, as opposed to going out and buying something today. And we're being wise about the money that they're spending. We're being wise about the government's money. We have to be stewards of the resources that we're given. So instead of going out and buying this giant rack of systems so that I can run something for a month and then it sits there idle, I can scale up something, I can run a workload, and then I can shut it down. So that to me is being a wise steward as opposed to going out and spending that money on a physical system. So I have time for one more question, then I'll be here afterwards to answer any others that you have. So.
For your security, do you get a government accreditation for your classified network?
So as you saw, this was unclassified. So this is infrastructure on demand. I'm not authorized to talk about our secure environment. There is a secure version of this, but I can't talk about that. We are working down the accreditation route today. Yes, we are working down the accreditation route today to accredit this in our classified. Thank you very much for coming. I'll be here after the event.